Closures in Python. A closure in Python is a function that remembers values from the scope where it was created. Most of the time, this means an inner function keeps access to names defined in an outer function, even after the outer function has finished running. In Python, decorators use this concept a lot. All function objects have a __closure __ attribute that returns a tuple of cell objects if it is a closure function. What are closures? Closures are functions that are created when we define a function inside another function. The outer function has some values that are used by the inner function, just as those values are like global values. It looks like the outer function works statically, and the inner function works dynamically. It is created when one function is written inside another function, meaning nested functions. The inner function takes reference variables from the outer function. The outer function returns the inner function. Syntax of closures. It has the following syntax: def outer, x, def inner, y, return x plus y return inner. Here, outer, it is a user-defined function that accepts a parameter. Inner, it is another user-defined function that accepts a parameter and is defined inside the outer function. Inner function is a nested function of the outer function. Parameter. The following parameters are used in closure functions. X. It contains a value given by the user statically. Y. It contains a value given by the user dynamically. Return. The inner function is returned to the outer function, and the outer function is returned to the function call. Examples. Let's take some examples of closures in Python to understand them better. Example 1. Using a simple example. The following example demonstrates a simple way to use closures in Python. Hash define an outer function. Def outer, x, hash define an inner function. Def inner, y, hash returning the inner block result return x plus y. Hash returning the inner function return inner. Hash create a closure with x equals 40 closure equals outer 40. Hash calling the closure multiple times with different values of y, print, closure, 10, print, closure, 20, print, closure, 30. Output, 50, 60, 70. Explanation. In the above example, we defined an outer function with a parameter and an inner function with another parameter, then added both values inside the inner function and returned then after from the outer function, returned inner function. So, here we see that the outer parameter acts statically and the inner parameter acts dynamically. Then, we call the outer function inside the closure variable. Then, after we call the inner function multiple times to see dynamic changes from the inner function by using the outer function parameter as static. Example 2. Using a string value. The following example demonstrates how to work with another data type object within closure functions. Hash define outer function def greet, day, def display name, hash define inner function return f. Hello, name, today is, day. I hope your day goes well. Thank you, return display name. Hash calling the outer function greeting equals greet, Monday. Hash calling the inner function. Print, greeting, John. Output. Hello John, today is Monday. I hope your day goes well. Thank you. Explanation. In the example above, we define an outer function called greet, that takes a parameter named day, which keeps its value unless changed. Inside greet, we create another function called displayName, which shows the name of the person calling it along with a greeting message. We then return the displayName function from greet. After that, we call the greet function, store its result in a variable named greeting, and finally call the inner function to print its result. Example 3. Using a static or default variable inside the outer function. The following example demonstrates how to work with a static or default variable inside the outer function. Hash defined a make underscore counter. Function def make underscore counter. Hash assigned a default value count equals 0. Hash defined a closure function def increment, non-local count. Hash increment the counter by 1. Count plus equals 1. Hash return updated count return count. Hash return increment function return increment. Counter equals make underscore counter. Print, counter, print, counter. Output. 1, 2. Explanation. In the above example, we have defined a function named make_counter. Function which does not accept any kind of parameter inside its parentheses. We defined a default variable named count that is assigned a value of 0. We defined another function which is a closure or called the inner function named as increment. Then inside that function, we tell the compiler that the count variable is non-local, meaning a global variable. In the next statement, we increase the count value by 1 and return the variable. Then again, we return the increment function from the make_counter function to the calling function and store it in the counter variable. Then, at last, we just print the counter function. As many times we call the counter function, the value of the count variable is increased by 1, and the updated value is printed every time. That's all for this video. Join our WhatsApp channel and developer community channel on WhatsApp to get knowledge about latest technology and stay updated in community channel. Links in the description.